Admittedly, the term sixth-generation fighter aircraft is nebulous or vague, and can be used to mean different things to different parties. However, it increasingly seems as if America's next-generation air dominance (NGAD) concept is informing a general consensus of some must-have attributes for sixth-generation fighters. These attributes include a native level of compatibility with DEWs, such as high-energy lasers (HEL), and high-powered microwave (HPM) weapons, or the capacity to lead or manage manned-unmanned teaming (MUMT) formations involving drones. Given the design of the Chengdu J-36 and China's broader development work across unmanned combat aerial vehicles, UCAV, DEWs, electronic warfare, EW, and smart munitions, the J-36 aligns with the high-level concepts for sixth general fighters. During the 2022 Zhuhai Air Show, the Chinese industry offered an indication as to the direction the PLA could take with its next-generation fighters. For example, the display below largely embodies many of the airframe design characteristics now seen in the J-36, bar the third engine. The J-36 leverages a tailless diamond wing fuselage. This approach omits the need for vertical stabilizers, reducing the aircraft's radar cross-section (RCS), while also improving the aircraft's drag and fuel efficiency. These design attributes indicate that China nurtured a credibly strong technology base for advanced flight control systems. Its expertise in the area has reached a point where it does not need to incorporate traditional tailplanes. One of the unique and unexpected aspects of the J-36 is that it relies on 3 turbofan engines. Currently, these engines might be the WS-10C, but this may be a transitional or temporary solution until a more advanced powerplant is available. Chengdu may be waiting for the WS-15 to become available, which reportedly provides both supercruising and a greater thrust for an improved thrust-to-weight ratio. However, it is worth noting that the choice for 3 engines may not be due to the size of the aircraft alone, but to achieve a specific capability set in the future. Basically, 3 engines would allow the J-36 to generate significant electrical power, a key need for supporting its advanced avionics, different sensors, high-output EW systems, and potentially DEWs such as HELs and/or HPMs. In other words, the choice for 3 engines has less to do with sustaining the J-36's size or weight, as one might assume with a traditional design approach, but to enable its role in China's next-generation air warfare vision. In this context, the J-36 would serve as both a focal node managing a formation of UCAVs, smart munitions and other assets, as well as a long-range, high-performance standalone combat aircraft. In fact, even if one were to restrict the J-36 to solely being a focal node for managing or leading MUMT formations, the effective use of that could rely on electronics. Basically, to manage drones at scale, one would need on-board extensive computational power, and to run that alongside high-powered data links for two-way communication will require lots of energy. This electronic stack would not only involve the processing as well as sensor or radio arrays, but also the required cooling systems. The way a fighter generates electricity is through its engines. In theory, perhaps 1 or 2 engines could be sufficient, if the platform's roles were restricted to specific missions, such as MUMT alone or only deploying DEWs. However, it seems that China is working to make each J-36 an individually versatile system, one that can play multiple key, and to be clear, power-intensive roles to support UCAVs and smaller crewed assets. To support this mission, it is possible that the J-36, or some future variant, could adopt a variable cycle engine, VCE. VCEs enable individual turbines to spin at different or varied speeds rather than one fixed speed for all. It can lead to better fuel efficiency and may tie into supporting other power needs better, such as those of electronic subsystems. The potential MTOW of the J-36 could be from 50 tons to 60 tons, making it significantly larger than traditional strike fighters. This large size likely translates into significant fuel volume and large internal weapon bays, enabling for long ranges and heavy payloads. Currently, one can only speculate as to the range and payload specifications. However, one can infer that China's principal goal in terms of reach is to be able to cover the first island chain, i.e., Japan, Taiwan, Philippines, and Indonesia. Thus, a combat radius for covering the first island chain, ideally without mid-air refueling, could be expected. In turn, the use of long-range standoff weapons, SOW, can help extend the J-36's strike and impact reach to potentially the second island chain, i.e. all of Indonesia. From a payload standpoint, one can expect the J-36's internal weapons bay to support a wide assortment of munitions, from new air-to-air missiles, like the ultra-long-range PL-17 with a speculated range of over 300 kilometers 11, to precision-guided glide bombs PGB, and air-launched cruise missiles ALCM. However, munitions may not be the sole purpose of the weapons bay, even if it can carry a large payload. Rather, the internal weapons bay could be used to house DEWs and other non-kinetic equipment. Moreover, instead of carrying its own munitions, the J-36 may use its electrical output to leverage new high-powered data links and in turn, coordinate UCAVs to deploy their munitions. Once again, the point of the J-36 is not to treat it as a traditional fighter, but a focal node in a wider air combat system. This system will include UCAVs of varying sizes, possibly including relatively large drones that may match up to small crewed fighters in size. For its own weapons complement, the J-36 may eschew traditional munitions and lean on DEWs instead. Its three-engine configuration speaks to a focus on power output, one of the key constraints alongside the size of the housing platform of many DEW types. Of course, the J-36 seems to leverage its own unique performance advantages. For one thing, its three-engine configuration and slimmer airframe may result in both a stealthier and more aerodynamic design. In terms of the latter, the J-36 could potentially be able to fly at high speed, at least Mach 2, giving it a stealth and speed advantage. This can be used to ensure the J-36 is difficult to track and engage, which in turn makes it harder to neutralize a MUMT formation led or managed by this fighter. In addition, the J-36 could also leverage its own EW suite to jam radars, including those on seekers, and potentially communications between enemy air assets. One could potentially see a scenario where the J-36 operates at high altitudes and flies at high speeds. In parallel, the Shenyang JXX J-50 could be the slower, maneuverable and lower flying threat for more traditional fighter-type operations, like long and or short-range air-to-air engagements and combat air patrols, CAP, for example. To reiterate, there is no consensus on the specifics of what constitutes a sixth-generation fighter, 6GFA. However, the Chengdu J-36 and Shenyang JXX J-50 both carry specific airframe design elements that make them distinct and much improved over all other current generation aircraft, including America's cutting-edge platforms.